Hello, my name is Tayfun, and in this lecture, we will create a simple scanner to scan hosts in our local network and find their MAC addresses. In order to create the scanner, we need to first understand what address resolution protocol is and how it can be used for creating a network scanner. So, address resolution protocol in its simplest form is a translation tool that helps us to translate IP addresses into MAC addresses. So whenever a device needs to communicate with the device within the same network, same local network, it needs the device MAC address. So let's say for example, let me actually open my diagram here to see, so we're more detailed here. So here. So let's say the Tayfun's device wants to communicate with Johnny's device in a local network. So in order to find the MAC address of Johnny's device, Tayfun's device will first look inside the internal list maintained by it called the ARP list here. So for example, every computer has this kind of list here. For example, this IP and MAC address. For example, this IP has this MAC address. This IP has DUS, IP2 and MAC2, or IP this here and MAC this. So most computers or networks, we have those kind of lists that stores the ARP list. So now in order to find the MAC address of Johnny's device, the Tayfun's device, as I said, will first look inside an internal list maintained by it called the ARP cache. ARP cache. It's also called ARP list in some. So it will check the ARP cache to see whether Johnny's device IP addresses are mapped to a physical MAC address inside its table. So this is called ARP list, ARP table as well. So you can check the ARP table on your PC by typing this command here. So let me go back to Linux here and here. So you can check the ARP list by using this ARP and A. That's it. So here you can see that it lists out the IP addresses corresponding MAC addresses associated with them. So you can use the same command in Windows as well. So if the corresponding MAC address of the requested device is not present locally here, so as you can see here, we are not seeing the another IP address other than ours, in this case it's Tayfun's device. So this Tayfun's device will send out a broadcast request to the whole network to ask which device has this respective IP address. Here, actually, let me get my pen here and draw some things on the screen. So here, as I said, Tayfun's device will ask to all of the devices to ask this if they have the IP addresses. Actually, the Tayfun's device not ask that like that. Instead, this here. Instead, Tayfun's device will ask the router to ask this IP address here. In this case, router is gonna find the Johnny's device, and after that, Johnny's device will send a signal back. So in our case, since we are asking who has this IP address, in this case is Johnny's device. So these devices that are not Johnny's device will ignore this request. while the joins device will give out a reply with the corresponding MAC address here, right? So here, this way, the Typhoon's device will get to know the MAC address of the joins device. So once the both devices get to know each other, the communication between them can follow. So once the Typhoon's device gets the MAC address of joins device, it will update the ARP table and it will write, for example, joins device has this IP and this MAC, right? And after that, they will be like friends, right? And that's it. So here you, in this illustration, you've seen how this works here. And now that we understand how ARP works, we can start working on creating our own ARP scanner with Scapy to find out the MAC addresses of these devices. So you might be wondering why we need an ARP scanner. Well, knowing the MAC addresses of a device can help us to perform man-in-the-middle attack. So as known, meetem here. So meetem, man-in-meetem attack, which we will perform in next lectures. So I'm waiting you in next lecture to write that program. Hello, my name is Stefan, and in this lecture we will create a ARP scanner, address resolution protocol scanner, using Scapy. So the address resolution protocol works on the Ethernet layer. So using Scapy, we will firstly import the Ethernet layer here. So now let's open the PyCharm or IDE, and now we will firstly write the import the statements. So here, so in previous versions of Scapy, you can import the Ether, ARP, Ether, ARP, and SRP libraries like that. But in this updated version of Scapy, you can't import. Instead, you will do this here: import firstly, and you will get that Ether libraries from import from Scapy layers, and after that, you inside the Scapy layers you will import Ether and ARP from that, and layers L2, and you will enter Ether from that. Also from Scapy.layers L2 import also ARP from L2 here, but the S for SRP you will write this Scapy layers recipe here, or I think it might be the send recipe here, send recipe or send recipe here, and we will import SRP from the send recipe library. So now so we imported the layers. So if all the bits of MAC addresses are set to 1, this means that packets is broadcast and it should go to every device in the network. So Scapy uses hexadecimal representation, so we will create this broadcast variable for to denote the broadcast address. So here broadcast, and we will use set all the variables to 1, ff, and ff. That's it. So then we can create an Ethernet layer packet and put the destination as a broadcast, right? So we will also need to define the IP range we want to scan. In my case, let's actually find what our IP config is and what broadcast IP is. And it's actually clear that if config, and as you can see here, our net mask is this, our init address is this, and our broadcast address is this. So in this case, we will scan we will scan from 19, oops, we will scan from 192.168, 13 from 13 0, and from 192.168, 13 to 255, right? So now what we're gonna do is we will write IP range here, and after that we will write, oops, not this, here, 192.168.13. So 192.1, oops, instead we will use the strings 192.168.13 and 1, and we will do slash here 24. So this 24 means that we want to scan from 0, from last digit 0 to 255. You also learn, you can actually, I think you learned this in previous lectures here, TCP/IP lectures. So, but I will explain this again. So this represents that we want to scan all the devices starting with IP address 192.168.13.1 up to 192.168.13.255. So the last 8 bits are called the bit mask and represents the number of hosts we want to scan. So remember that an IP address is 32 bits, and we say here that we want to mask 24 bits. So the remaining 8 bits are addressable only. So which means that we are only scanning the last 256 hosts in the network. So now to create the ARP layer packets, we will use the my ARP layer, and we will use this ARP library that we imported from the escape layers L2 packet. And now ARP, we will enter the PDST equals IP range. So that's it. So now that we have created 2 layers, Ether and ARP, next we will create a packet with both of these layers. So we will packet the equals Ether layer here and ARP layer. And we also quickly need to create the Ether layer here. It's so easy. We'll just Ether layer, and after that we will enter the Ether, and inside this parenthesis we will enter the destination DST as our broadcast, right? So we will get this broadcast inside this Ether layer. That's it. So after that, what we're gonna do is, so what we're gonna do is now we will send this packet as a broadcast. To do this, we need to SRP function. So ANS here, we will use the ANS and UNANS. Here, as we will use SRP, we will enter the packet. The interface is going to be, in this case, let's say the ETH0, because we will use ETH0 here. And timeout is gonna 2, I think. Yeah, 2 is okay. So packet here is the name of a packet we want to send, and ePhase is the network interface card NIC we want to use to send this packet, and the timeout, as you can see, it is to make sure that if we don't get a reply in 2 seconds, this means that device is most probably offline. So SRP returns both answered and unanswered packets. So we are interested in answered packets from online devices only. So now to get the IP addresses and MAC addresses of the online devices, we can write the for loop. So we can iterate over the answer to see the IP and corresponding MAC addresses. So for SND and RCV in A and S here, and we will create a new IP. So let's use this. So we will create a new IP. This will take, actually, let me see if it's recording. Yes. So IP here, we will create a new variable IP, and we'll take the RCV, parenthesis ARP here, and PSRC. That's it. And after that, we will also use the MAC address here. So RCV as well. In this case, we will use the ether and SRC. And after that, we will print the online, or first we will write the IP. This actually, let's use the format here. So IP, we will use the IP. So as you can see here, with receive arp.psrc, we got the IP address from the receive array, and also we got the MAC address from the RCV with saying ether here. So now what we're gonna do is, after that, we'll use the new line, or we can also use tab. So it will be here. And after that, we will use MAC. Actually, let's use the 2 tab. So MAC address is going to be MAC. That's it. So here, the RCV represents the packets that have been received by the sender. So to get the IP address, we can use the ARP layer, and to get the MAC address, we can use the ether layer. So remember, the fields set in the packets correspond to the respective layer. So the complete code will look like this here, and let's run this, check this. And as you can see, we got an error here in line 12. So what's the problem here? So the permission error. So as you can see, we need to run it with sudo here. So we will go to this, so it will nice terminal look, and we will cd to PyCharm projects to the phone ls, and as you can see, this is our program. So now what we're gonna do is main.python sudo here, of course, sudo python 3 main.py, and call it. And as you can see here, we got these packets here. So as you can see, we received 7 packets and got 3 answers, remaining 253 packets. And as you can see here, now you can see the MAC and IP addresses of all the devices available in the network. And let me if config, and let's see what our MAC address is here. So actually, we can also let's get a new Windows machine onto our network and see if this program of ours will show that newly added Windows machine to it. So I will now, let's turn on the Windows machine and virtual machine here, and we'll get back in 2 seconds. And here I added my Windows machine to the same network, and now let's check this out. And as you can see here, we added the new MAC address and new IP address and MAC address to the output. And here, let's see if this is the MAC address of our Windows machine. And here, as you can see it, we have the same IP address on our target machine. And here, let's see on the Linux side. Oops, sorry, not like this. on here, and as you can see here, it's the same address here. So we successfully wrote our program here. You can see that all the results obtained in our scan match these values. So you can take a look at these values, or you can add new devices. You can also like, if there's 100 devices on your local network, you can scan all of these devices according to their MAC addresses, IP addresses. So here, also keep in mind that there was some additional report here. Let's actually use that now. So now let's go to our Kali machine. So here you might see this weird 254 IP address. So here, this represents, this here MAC address and this here represents the DHCP server. So DHCP server assigns IP addresses to the devices in a network when the devices are configured to automatic IP assignment. So, and also this represents the default gateway in the network. So in this section, we learned how data is sent from one device to another over the network. We learned about how data is encapsulated in the TCP/IP protocol and what fields are added to each header. Next, we learned about a very important network manipulation and packet crafting tool called Scapy here. And we also learned how to craft packets using Scapy and how these packets can send over the network. So we then learned about address resolution protocol, and finally we created an ARP scanner to get our internet protocol addresses and MAC addresses of live devices in our network. We also added Windows device. We've seen the IP and MAC addresses match, and in next lectures we will do more awesome and fantastic practical topics like this. So I'm waiting you in next lecture.